Good day, students. Welcome to mathgotserved.com, where we don't just solve, we teach. In this clip, we're going to be going over problems 6 to 10 of the June 2019 Algebra 2 New York Regents exam. As indicated in the previous installment of this review series, this is a step-by-step consideration of the solutions to the problems. If you need something quicker, feel free to go to our website at mathgotserved.com under New York Regents, and you gain access to the transcripts of this video, and you can consider it at your own pace. Do not forget to subscribe to our channel so you can get updates to the times when we upload the remainder of this review series. Alright, let's take a look at question 6. In question 6, we're being assessed in how to generate exponential models from graphs. Alright, and we're going to be generating our model numerically. Question 6 reads, the graph of y equals f of x is shown below. So we have the exponential graph of the function shown below with 3 points indicated. Question, which expression defines f of x? Alright, so we have 4 expressions here, and the question is which of these ones define this function that we have. Alright, so what we're going to do is we're going to basically carry out a test. We're going to test each of these functions using these 3 points, and whichever function satisfies these 3 points, that will be the correct function. Okay, so we're going to test the functions with the 3 points. Alright, let's go ahead and start with function number 1. Alright, so for function 1, we have f of x equals 2x. Now, should we even bother checking this function at all? The answer is no. Why not? If you take a close look at this function here is a linear function. What does that mean? It means that when you draw the graph of this function, it's going to be a straight line. Okay? A straight line with y-intercept of 0 and a slope of 2. So this graph right here is not, you see it's curved, it's not a straight line, it's an exponential function. So based on that observation alone, we should automatically know that number 1 is not the answer. Alrighty? Now let's assume that we didn't observe that detail. Alright, we just want to go through it, just want to test the points. We'll just test the points one by one. Okay, so we start with point number 1. P1 is the point 2, 10. Alright, so let's call this P1, P2, P3. These are the 3 points we're testing. Alright, so P1 is 2, 10. So the question is, when I plug in 2 into the function, do I get 10 as the output? Okay, so is f of 2 equal to 10 for this particular function? Well, let's see. F of 2 means you plug in 2 into this function, right? So f of 2 is 2 times 2. Is 2 times 2 equal to 10? 2 times 2 is 4. Is 4 equal to 10? This is false. It's a no-no. Alright, we're not surprised that it doesn't match. So number 1 is not the answer. Alright, let's move to option 2. Option 2, 3, and 4 are all exponential functions. How do we know? Because the variable term, the x, is in the exponential position. It's been exponentiated. So all these 3 are exponential functions, so we have to check them all. Okay? Alright, let's start with continue with option 2. Option 2, the function is 5 times 2 to the x. Uh-oh, I didn't write it correctly. So 5 times quantity 2 to the x. Alright, so we're going to start testing. We start with the first point, point 1, which is 210. So the question is f of 2 equal to 10 in this second function? If I plug in 2 into the function, do I get 10 as an output? Well, let's see. The function is 5 times 2 to the x, so we're going to go 5 times 2 raised to the input, which is x. Is it equal to 10? Is it? The x value is 2, so we can replace that x right there with 2. Just plug in 2 into the function. When we're plugging 2 into the function, we're going to have 5 times 4. Is 5 times 4 10? 5 times 4 is 20. Is 20 equal to 10? The answer is no, this is false. So that helps us to see that option 2 is not the answer, because when we plugged in 2 into this function right here, we got 20 and not 10. Okay? Alright, so let's move on to the next one. Option 3. Option 3, we have the function, so another exponential function, 5 times quantity 2 raised to the x over 2. Okay? Let's start with the first point, P1. P1 is 210. So is f of 2 equal to 10 in this case? We are repeating the same procedure. All we're doing is just plugging in the point into the function and see if we end up with a true or false statement. Okay, so we plug in 2 here. We're going to have, let me move my function up a little bit so you can see it. Okay, there you go. When we plug in 2 here, we're going to have 5 times the quantity 2 to the 2 over 2. Is that equal to 10? 5 to the 2 over 2. 2 over 2 is 1. 5 times 2, is it equal to 10? 5 times 2 is 10. Is 10 equal to 10? Absolutely. Oh man, looks like this is the answer. But is testing only one point sufficient? The answer is no. We gotta test all 3. Okay. So let's move on to point 2, P2. Point 2 is 420. So the question is f of 4 equal to 20? So plugging 4 into this function, if we plug in 4 into the function, we have 5 times 2 raised to the 4 over 2. Is it equal to 20? 4 over 2 is 2, so 5 times 2 square, is it equal to 20? 2 square is 4, right? So it's 5 times 4, is it equal to 20? It certainly is. Looking good. Let's try the third point. It looks like this is going to be our answer, but let's not make any assumptions here. Let's try the third point, P3. Or another thing you can do is plug in the first point into the last option and see if it works or not. Okay? So I'm going to try the third point. P3. Point 3 is the coordinate 6, 40. So does this function here satisfy? Is f of 6 of this function, is it going to give me the output of 40? Well, let's see. F of 6 involves us plugging in 6 into this function. So it's going to be 5 times 2 to the 6 over 2. Is that equal to 40? And then we have 5 times 6 over 2 is 3, 2 to the third. Is that equal to 40? And then when we simplify that, 2 to the third is 8, right? So is 5 times 8 equal to 40? 5 times 8 is 40, right? So is 40 equal to 40? It certainly is. So ladies and gentlemen, the correct answer is 5 times 2 raised to the x over 2. Alright, another way that you can do this problem, since you're allowed to use a calculator on the exam, is by making a use of the graphing calculator. Okay, so what you can do in this, if you want to use a graphing calculator, is you simply enter these 4 functions into the graph, take a look at the table, and see if see which one satisfies these 3 points. Okay, so let's do that real quick. So the first function is 2x. The second function is 5 times 2 raised to the x power. So the only tricky part in this process is being able to enter the functions correctly into the calculator. Okay, and then the third one is 5 times 2 raised to the parenthesis x over 2. Close the exponent and then close the power and then close the exponential term. Alrighty, so 5 times 2 raised to the x over 2. And then the last one is 5 times 2 raised to the 2x. Now, since this is 2x, be sure to group it in the parentheses, 2x. There's some calculators that do the grouping for you so you can see exactly what's going on, but this is doesn't have that feature, so there you have it. Okay, so let's make sure we have everything correct. 5 y equals 2x. The next one is 5 times 2 to the x. The next one is 5 2 raised to the x over 2, and then the last one is 5 times 2 raised to the 2x. Okay, alright, so now I'm going to go to my table setup, and I want it to ask, so the default setting for the independent is auto, so I'm going to have it do ask. Okay, so I want it to ask me what input I want it to generate the output for. So you go to have that selected, and then go to table, second function graph. So this is the table right here. Oopsie, it already has it all filled out. Okay, let's do this. I'm going to clear that. Okay, there was something wrong with my previous calculator, so I'm switching to a different one. Okay, anyway, so you have this entered. I have everything entered in the second calculator. And then table setup, ask. Okay, I wanted to ask me for the independent variable. Alright, so second function graph will take me to the table. Alright, so I'm just going to enter what I want, which is 2. Enter. Bam. Alright, so if you take a look at that, for x equals 2, you notice the output. For the first one, I got 4, which is wrong. Second one is 20, which is wrong. Third one is 10. Bam, that's the correct answer. So we can automatically see that that's the correct one right there. Okay, and then you could do, if you want to do them all, you could do 2, 4. Let me see if it does it override it. So 4, if you look at it, the first one is wrong, second one is wrong, the third one is correct, 420. Okay, so you can just enter it into the calculator, and then you can have the calculator do the calculations for you, and then just compare with what you have, and then you can see which the correct answer is. So if you are allowed to use a graphing calculator, it's definitely the fastest way to do it. But without a graphing calculator, the best strategy would be to just plug in the points into the options and see which one satisfies all the points. Okay, so this is basically how you generate an exponential model using the graph with specified points. Alright, let's take a look at question 7. In question 7, you're being assessed on how to verify if factors are roots of a polynomial using the factor theorem. Okay, question 7 reads, given p of x equals x to the third minus 3x squared minus 2x plus 4, which statement is true? So we have 4 statements here. Okay, we have the factors and we have the implied roots based on what the factors are. Okay, so before we start writing down the solving the problem, let's go ahead and note what the factor theorem is. Okay, so if you know what the factor theorem is, then you are in a good position to solve the problem. Alright, so the factor theorem is as follows. If x minus a, okay, if x minus a is a factor of some polynomial, let's say f of x, or let's put it this way, x minus a is a factor of f of x if and only if and only if f of the related root for that polynomial factor, which is a, is equal to 0. Okay, so that's your factor theorem right there. So we're going to be using this factor theorem to go through the problems. Alrighty, so let's take a look at the factor theorem first, and then let's take a look at the options that we have. So factor theorem says if you plug in the related roots to the factor, you're going to get 0. Take a look at the 4 options that we have here. Which of them involves plugging in a root into a polynomial and getting 0? Options 3 and 4 meet that criteria. If you look at option 1 and 2, it's being plugged, you're getting 2 as an output. This does not match up with the factor theorem. Okay, it doesn't satisfy the conclusion of the factor theorem. So we automatically eliminate option 1 and 2 because those two statements do not tell you if a polynomial factor is a factor of a polynomial. Okay, all right. Now, option 3 and 4 look more like this. Okay, x plus 1 is a factor because p of 1 equals 0, and x minus 1 is a factor because p of 1 equals 0. So these two harmonize with the factor theorem because they've been set equal to 0. So the question is, which one of them is incorrect? The problem should be connected with this piece right here, p of 1. Both of them are using p of 1. So is that always the case? Does it matter what you plug in? Well, it certainly does. So what we're going to do is we're just going to go ahead and test both of them out and see which one actually works. Okay, so using the factor theorem, we're going to test the first factor, x plus 1. Is this a factor? Well, to do that, what you do is you find the related roots. Set x plus 1 equal to 0. Okay, so when you solve this, you subtract 1 from both sides. You have x equals negative 1. Okay, so x equals negative 1. Now we're going to plug in negative 1. We have to find if p of negative 1 is equal to 0. Hold on, wait a minute. This says, check, this says p of 1, and this is p of negative 1. Do you see the problem here? The related root for x plus 1 is negative 1. X plus 1 tells us if p of negative 1 is a root. X plus 1 does not tell us if p of 1 is a root. Okay, so based on that alone, we can automatically eliminate option 3. The answer should be option 4. Okay, so let's just show you how that works. So for option 4, we want to test x minus 1. Okay, so to do that, you say x minus 1 equal to 0. You solve it for x. X equals 1. You add 1 to both sides. Okay, and then we're going to test to see if the polynomial evaluated at 1 is equal to 0. Okay, so let's do it. P of x is x to the third minus 3x squared minus 2x plus 4. So p of 1 simply means we substitute all the x's with 1. So we have 1 to the third minus 3 times 1 squared minus 2 times 1 plus 4. Okay, we're just going to PEMDAS this real quick. Do the exponents first. 1 minus 3 minus 2 plus 4 minus 1 minus 3 is negative 2 minus 2 plus 4 is positive 2 equals 0. Bam! Excellent. We can see that option number 4 is the correct answer, because if x minus 1 is a factor, based on the factor theorem, x minus 1 is a factor if and only if what? Its related root, which is what you get when you set is equal to 0 and solve p of 1 is equal to 0. So option 4 is the only correct statement that matches with the factor theorem correctly. Alright, let's take a look at question 8. In question 8, we were looking at how to apply the properties of exponents, namely the power of a power and the nth root properties. Alright, question 8 reads, for x greater than or equal to 0, which equation is false? Now, before we go ahead and solve the problem, let's refresh our memory on what the properties of exponents that we're using for this problem are. Okay, the first one is the power of a power property of exponents. Alright, so what is the power of a power property of exponents? If you have x to the a raised to the b power, if you have a power raised to a power, guess what you do? You multiply the powers. Simple and short. Alrighty? 2 is the nth root property. Nth root property. If you have n the nth root of a power, the nth root of, let's say, x to the m, this can be written as a rational exponent, namely x to the m raised to the 1 over m. And then we can apply, raised to the 1 over n. And then we can apply the power of a power property here. And then that's going to be, this is going to be x to the multiply the powers m over n. Okay, so these are the two properties that we're going to be using. Now, let's go ahead and apply this to all the problems, and whichever one fails, that's automatically the answer, because we were looking for which one is false. Option number 1, we have x to the 3 over 2 raised to the third power. Is this equal to the fourth root of x to the third? If it's false, then that's the answer we're looking for. Alright, so we're going to use the power of a power property for the first one. So how do we, for the left side of the first one, so for that one we just multiply the exponents. Okay, so it's going to be x to the 3 over 2 multiplied by what? 2 over 1. Okay, we multiply the exponents. And then on the right side, we're going to use the nth root property. This becomes x to the 3 over 4. Okay, so the power on the inside is the numerator and the index becomes the denominator, like that. And then this one simplifies into the 2's divide out, x to the third. Is x to the third equal to x to the 3 over 4? No, this is false. Alright, so this is the answer. Option number 1 is the answer because it is false. Okay, let's just do the others just to show you that they are true and to review your the use of these properties that we have here. Okay, x to the 1/4 equals the fourth root of x to the third. On the left side, we use the product power of a power property. Just multiply the powers. This is 3 over 1. When you multiply 3 over 1 times 1 over 4, you have 3 over 4. On the right side, nth root property, x to the 3 over 4. Are they the same? Yes, that's true. Okay. Option 3. What if we have x to the 3 over 2 raised to the 1/2 power? Is that equal to the fourth root of x to the third? So using the power of power property here, multiply the powers, you have x to the 3/4. Is that equal to the right side? Use the nth root property, x to the 3/4. Are they the same? Absolutely. Statement 3 is true. And then the last one, last but not the least, option 4, you have x to the 2/3 raised to the second power. Is that equal to the fourth root? Getting ahead of myself. Equals. Is that equal to the third root of x to the fourth? On the left side, you apply the power of a power property. Multiply the powers. You have x to the. So you just multiply 2/3 times 2 over 1. Numerator times numerator 4. Denominator times denominator 3. On the right side, using the nth root property, this becomes x to the 4/3. Are they both the same? They certainly are. This statement is true. So we see why the answer to question 8 is option 1, because all the other statements are true, hence they need to be eliminated. Alright, in question 9, we're going to be looking at how to find the inverse of functions. We're looking at a linear function in this example. Question 9 reads, what is the inverse of the function y equals 4x plus 5? So let's refresh our memory on the process involved in finding the inverse. Okay, so recall how to find the inverse. So the first step you want to do is you want to switch x and y. Okay, because your input is going to become your output and your output becomes your input. That's what the inverse is all about. And then secondly, you just solve for y. Okay, that y is your inverse. Okay, so we're going to apply this procedure to this problem. It's pretty straightforward. The linear function we are inverting is y equals 4x plus 5. We'll start by switching the x and the y variables, so y and x will get interchanged. When we carry out the switch, we're going to have x equals 4y plus 5, and then now just solve for y. It's a two-step process. Subtract 5 from both sides and then divide by 4. Okay, so when we subtract 5 from both sides, switch the equation around, we'll have 4y equals x minus 5. And then to get y isolated, we're going to divide every term by 4. So divide by 4, divide by 4, divide by 4. And your final answer is going to be y equals 1 over 4x minus 5/4. This is the inverse of y. Okay, so that's basically how you find inverses. Now let's see which option is the correct answer. Our answer is option number 2. Okay, so there you have it. Alright, let's take a look at question 10. In question 10, we're going to be assessed on how to identify geometric sequences when the scenario is presented in a verbal format. Okay, so geometric sequences can be presented numerically, it can be presented as plotted points on a graph, or it could be presented in a verbal format, as we are going to be looking at in this problem. Question 10 reads, which situation could be modeled using a geometric sequence? Alright, so before we get started, let's go ahead and refresh our memory on how we can distinguish between a geometric and an arithmetic sequence. Okay, so recall. What is a geometric sequence? A geometric sequence is one where a term differs from the previous by a common factor. Okay, what's important here is how it grows. Geometric sequence involves growth by repeated multiplication. Okay, repeated multiplication by the common ratio. Alright, and then the model for the nth term for geometric sequence is an equals a1r to the n minus 1. Alright, for an arithmetic sequence, we're looking at growth by what? By repeated addition. Okay, so that's the difference. One is multiplicative, the other is additive. Okay, repeated addition. So for the nth term for an arithmetic sequence is the first term plus the number of terms minus 1 multiplied by the common difference. Alright, so when you're looking at geometric sequences, you're looking for things like for or rate. Okay, for an arithmetic sequence, you're looking for terms like additionally, more, added, stuff like that. Alrighty, so let me just put the side note here. So for this one, you're looking for things like rate or for or off. Okay, these two indicate multiplication, and then for arithmetic, you're looking for addition, more, or addition. Okay, anything that includes an increment by a certain fixed amount. First one, a cell phone company charges $30 per month for 2 gigs of data and $12.50 for each additional gigabyte of data. The growth here is additional. Additional is arithmetic. Okay, so it is not option 1. Our option 1 is an arithmetic sequence. So let's go ahead and write down what that looks like. So for this one, it's going to be n term an is equal to the initial term, $30, plus the number of terms minus 1 times the common difference, which is $12.50. Okay, so if you look at this model right here, this is an arithmetic sequence model, which basically indicates repeated addition of a common factor of $12.50. I'm sorry, a common difference, not common factor. Common difference of $12.50. Alright, let's take a look at question number 2. It says the temperature in your car is 79 degrees. You lower the temperature of your air conditioning by 2 degrees every 3 minutes in order to find a comfortable temperature. So what is this? Is this an arithmetic sequence or a geometric sequence? So the operation that we're looking at here is lower. Okay? To lower, what does that mean? It means to subtract. So lower means repeated subtraction. Okay, more is add, lower is subtract. So you're constantly subtracting 2 degrees every 3 minutes, 2 degrees every 3 minutes, okay, or 2/3 of a degree per minute. So this is repeated addition by a negative number. So this is not a geometric sequence. All right. So if you want to write the nth term for this, so you just have an equals the starting temperature 79 plus n minus 1 times the common difference, which is negative 2/3 here. It's negative because you're subtracting, okay? You're subtracting repeatedly. Alright, number 3. David's parents have set a limit of 50 minutes per week that he may play online games during the school year. However, they will increase his time by 5% per week for the next 10 weeks. Is this a geometric sequence or an arithmetic sequence? You have 5% per. That's the rate of increase. 5% per week is a rate of increase. So when you see percentage per period, that indicates the operation of multiplication. All right? So you constantly multiply by that, in this case, what is it? Growth rate, okay? 5% per week. So what is this going to look like? Well, first of all, this certainly is a geometric sequence because we are repeatedly multiplying by this growth rate. So what does the model look like? So the nth term here, so first thing you want to notice that the common ratio is different from the common difference, okay? The common ratio is different from the growth rate. The common ratio is going to be 1 plus 0.05. That's a common ratio. So the nth term for this geometric sequence is going to be the starting time, 50, times the growth rate, which is 1 plus 0.05 raised to the n minus 1. This is what it looks like, okay? And it is because we have 5% per period, which indicates multiplication every week by 1.05. So we have the answer is 3. We know option 4 is automatically not going to be the answer, but let's take a look at it anyway. It says Sarah has $100 in her piggy bank and saves an additional $15 each week. So this additional, what operation does it indicate? It indicates repeated addition. And repeated addition is how terms of an arithmetic sequence is generated. Okay, so the nth term for this one is going to be the starting amount, which is $100 plus n minus 1 times the common difference, which is $15 every week. Okay, so you can see model 1 is arithmetic, model 2 arithmetic, model 3 geometric, and that's the one that we want. And model 4 is arithmetic. Okay, so this is basically how you generate how you can distinguish or identify if a sequence is geometric or arithmetic when it's presented in verbal form. Thanks so much for taking the time to watch this presentation. I really appreciate it. If you found the contents of this tutorial helpful in your preparation for your upcoming Algebra 2 Regents exam, do give us a thumbs up. Your positive feedback is extremely important to us. If you have any questions or comments or special requests, just post it in the comment section below and we'll be more than glad to respond. Do not forget to subscribe to our channel for updates to the remainder of this review series and all the great math resources to help you master Algebra 2 and beyond. More support resources from algebra to calculus can be found on our website at mathgotserved.com. Do check it out. Thanks again for watching and have a wonderful day. Goodbye.